Okay, people who are joining the live stream, this is a meeting about language development for Wolfram Language, and we've got a variety of topics this morning. Let's start off with typesetting of around. I thought we had talked about this already recently.
Yes, we talked about this Monday, and I just wanted to show you how it looks in the transition between using plus minus and using parentheses with plus minus.
I see.
And so I have been working on these, and there are some arbitrary decisions on when to perform some of these transitions.
Okay. All right, so low exponents of 10. Oh, that's pretty ugly, isn't it?
Yes, though... Exactly, yes. So some cases here could be eliminated, so, the exponents. But then we may run into errors which are very small. So there is this balance there.
Okay, so let's consider this case.
Mm-hmm.
The alternative will be 0.12345, blah, 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 plus minus 0.00000, whatever. Now, we've agreed that we're never going to allow more than 3 zeros here. Is that correct? Before we go to this form. Is that right?
That's the transition I'm talking about, yes.
Right, okay. So in a case like this, I mean, again, if this went to 0.12345, then this would go to the sub-parenthesized form, whatever we're calling it. By the way, I really don't think that having unequal size... Are those two brackets equal sized?
At least that's what is specified in the boxes.
Okay. So I might argue, by the way, that even in this case, that we might try to have similar smaller parens here. Even in the case where we're going to scientific notation, I think it would look better if those were smaller.
Okay.
If they matched essentially the size of the error number rather than the size of the main number.
Okay.
So wait a minute. The tooltip you're just making for the sake of us seeing it. That's not intended to be a tooltip for users. Is that correct?
Exactly. Yeah.
Okay. Okay. So the question that you're asking is about this case here. So, I mean, one question is, and I don't know what the literature kind of implies about this, you know, whether 3 zeros is the right number or whether 2 zeros is the right number here.
Well, if you go further down, I have copied some examples from the particle data group, and they put lots of zeros there, further down. Yeah, there you see, they don't have any problem in putting tons of zeros.
Well, that's the lifetime of the muon. It's very accurately known. Well, they're so proud of the error being so small that they do that. But then for Avogadro's number, even with the same number of digits, they're not doing that, right?
Right. For example, in this article on the new measurements of the gravitational constants, they never use plus minus. They always use this parenthesis notation at the end. So I guess it depends very much on the group of people writing it.
Yeah. Well, the thing that I'm concerned about is our users, you know, for example, mean around won't generate. I mean, mean around you'd need to get 0.01 there, you would need 10 to the 4 in a first approximation. If I'm not mistaken, you'd need 10 to the 4 data points. Is that correct?
It depends on the values.
No, what I'm saying with the uniform distribution, right? To get 0.01, if it's 1 plus or minus 0.01 is the mean, then you would expect that you would need about 10 to the 4 data points, n squared data points. Is that not correct?
If they are about 1, yes, I would say so.
Right. But so the point that I'm making is the sort of naturally occurring in the wild kind of numbers that people are going to generate, they're mostly not going to, in other words, if they get a number that's 0.000001 error, okay? The fractional error in order to achieve a fractional error of order, 1 over, of order 10 to the minus n, you need on the order of n squared, not n squared, 10 to the n, 10 to that n squared, 10 to the 2n data points, if it's a statistical error. I'm just trying to estimate how common it's going to be for people who are just, running code and generating things to generate very small errors. And I think it's not going to be very common. I think most errors will be quite big. Most errors generated in the wild will be quite big. It takes, a huge, precision physics experiment to generate something which is a small error, I claim. Can anybody else think of scenarios where you generate small errors?
Well, anything in which the relative error is very small, if the number itself is very large, we will switch to scientific notation, and then the error will look small.
No. The error, but the error in these first things, in scientific notation, right? Mm-hmm. The number of digits here that are accurate for something statistically generated, the number of digits that are accurate won't be that large because you just don't have that much data. See what I'm saying? In order to get 5 digits of accurate data, you would need on the order of 10 to the 10 data points.
But you're thinking about the statistical cases, not just a measurement of something in physics.
No, but measurements in physics, again, to get more than like 3 or 4 digits, you need a precision physics experiment. Your everyday average, random sensor is probably accurate to 2 or 3 digits.
Oh, I see what you mean.
Right? So I think that what we should assume is that the most common case is 2 or 3 digits of accuracy, or maybe up to 5 digits of accuracy. And none of that is going to cause us trouble in these things, but for, so the case that you're saying, wherever it was, this case here is going to be very rare. I mean, who else can speak to this? Is anybody else here who's relevant to this? No. Okay. Is Itai here?
He's optional to ILD, so I don't think he's here today.
Okay. Okay. So my statement is, visually, we should make those parens smaller here. Mm-hmm. You're asking whether this breakpoint here is a reasonable breakpoint. I think it is. When do we get into this case? We get into this case because, I claim this case is a bit silly, right? I claim that case, I see. I mean, look, that case is not horrifying. I mean, that case is going to be very rare, in my view.
Mm-hmm. Yeah, so I guess the question is whether we prefer to have some slightly weird exponents sometimes or very small errors that are a bit more difficult to read.
I think it's better to have small errors than weird exponents.
Mm-hmm. So perhaps we can try to avoid exponents which are, say, below 3.
Yes, I agree. Where do we avoid exponents in standard machine numbers?
Well, we switch automatically to scientific notation for exponents 6 or larger, or minus 6 or smaller.
Okay. Well, how about doing the same thing here? That we don't use, that in cases up to 5, we're never generating times 10 to the, we're only generating it 10 to the 5, 10 to the minus 5. But we're not, so in that case, those errors, we could get in the case of 10 to the 5, right, we could get up to 5 zeros here.
Right, so expanding that would be too much because we would get like 9 zeros there.
Why would we get 9 zeros?
Because it's 10 to minus 6. Oh, so you are talking about switching to parenthesis notation, but still keeping the 10 to minus 6 in that example you're pointing at.
Actually, I wasn't thinking of that, but this is, I see. So you're saying that in this case, there will be 9 digits No, but the whole point is you can't have trailing zeros, so you have no choice, right? Because what you can never get is a situation where there are trailing zeros in the main number.
You can, yes. For example, there, if you go further down in that column, you have many trailing zeros there. I think that's fine. Because if you are specifying
that number exactly, but this is a rare case because most of the time, this wouldn't be correct. Right? Most of the time, the error would already be creeping in before you get to the trailing zeros.
Well, if the user specified that the error is so small.
I know, but that's a weird case because it's not going to come from physical measurement because physics doesn't have a preference for, powers of 10.
Yes, but I think it's a problem in the input. I mean, if we get exactly the input that we have there, I think we have to show this.
I agree.
Yeah.
I agree. Mm-hmm. But what I'm saying is I think that's a rare case where there are, but I'm saying there are cases where, okay. Well, so my statement is, okay, so how would we avoid this case? What do we do to avoid that case? In this particular case, we can say it's 0.12 whatever, and we just add more zeros here, right?
Yes, that case we could say 0.123457 and in parentheses 23.
Well, or we could just have more zeros. Or we could just say plus minus 0.000023.
Yes, we can do that as well. 0.1 plus minus 0.4 zeros, yeah.
Right, so the question is it worse to have more zeros or to go to this notation?
Mm-hmm. Yes, that's yet another thing. For example, in this paper, we were talking about the measurement of the gravitational constant. They have things like 10.2 and then in parentheses 1.7. So even the decimal point gets into that parenthesis, which is quite interesting.
That's crazy. That's very hard to interpret.
Yeah, I was trying to avoid those cases as well.
Okay, look, I don't like this case. I don't like saying times 10 to the minus 1.
Right.
So, okay, so we've got two choices. If we're going to avoid things below 10 to the 6, right, we've got two choices. We have more zeros or we go to paren notation.
Right.
Okay?
Mm-hmm.
I guess we should probably go to paren notation. Okay? So in other words, if there are more than 3 zeros in the error, we go to paren notation.
Right.
That would be my suggestion for the default.
Okay.
Okay, now meanwhile, a round form would parameterize these things. Is that correct?
Yes, that's the idea. Though, I mean, there are still so many things to parameterize that I'm trying to classify. Like, for example, what is the threshold? I have examples further down on the threshold. But before we go there, so there is this asymmetric case in which we have the same problem.
Well, wait. Let's look at this case here. Why is there a point? Why is there a decimal point after the 4 there? Oh, it's right. Yeah, that's right.
Mm-hmm.
I mean, it would be nicer if that was 1 plus or minus 4, wouldn't it be, without the decimal points?
I find it a bit inconsistent with the rest because these are all approximate numbers.
Yeah, all right. Okay. I provisionally agree with you. Okay.
Mm-hmm. So this is just the same situation as before, but because it's about the threshold of 35, it shows only 1 digit. But the problems are basically the same one.
Yeah, I don't think there's a huge problem with any of these.
Mm-hmm.
Okay.
Now,
except for these cases here, which I don't like.
Exactly. Yeah. So that should be 0.1.
Yes.
Mm-hmm.
Okay.
So then the problematic case here is when we go to the asymmetric case and we try to do the parenthesis notation, which I must admit I've never seen, then it becomes weird when we have errors of different number of digits because it's difficult to align. So in this case, we have this plus 4 minus 23. Meaning
I think it looks magnificent. I mean, I think that's, well, what does this actually mean?
Exactly. So it's the 4 with the first digit or the second digit of that pair?
Well, is it 40 or is it 4?
The truth is that it is 40.
Okay, so why don't we write 40? Why don't we make the number of digits agree?
Well, perhaps we have to do that, but the rule is, in general, is if you go above 35, then you show only one digit. I was trying to keep that rule, but perhaps here
I don't think that's going to work, because I wouldn't know whether that's plus minus 4, right? I just don't think that's knowable. I think if you've got 2 digits here, you've got to say plus 40 minus 23.
Okay, yeah. We can say in this case, we don't follow the rule of number of digits, yeah.
So let's look at this case here. So this case here, that's absolutely fine. That's hunky-dory. It doesn't matter, because that's
fine.
Right. So it's only in this case that we have to deal with that.
Right. But if we insist in having the same number of digits, I would also have the same number of digits in the other case, perhaps. For consistency.
This one here?
Yes.
No, I don't agree. I don't agree, because you don't know that the trailing digit there. I wouldn't do it. I don't think it matters. I think this is fine, because in the case of a very, very asymmetric error, which could happen, I mean, this is going to get exotic in the case of a very asymmetric error down here, but that's okay, because it is an exotic case.
Okay, I see what you mean. So then when we have the standard plus minus asymmetric, we keep the separate number of digits, but here we align them. Yeah, okay.
That's what I'm suggesting, yes.
Yeah.
George on our live stream is saying he was lucky to get 4 significant digits in experiments he did. Anyway, supporting my point of view that this is an exotic case. But again, the thing that we're going to see in the wild is people generating this from, let's say, a number theory experiment or something, generating it from data that they are producing, computationally. And I think then the n-squared argument holds. So I'm good with this. This is good. This is wonderful, actually. I mean, this is very nice. And don't forget to put in some of these tables in the documentation.
Sure. Yes. We'll probably have a tutorial dedicated to explaining details here.
Well, it'll be, nowadays, those are called tech notes.
Okay. Yeah.
Okay. So in terms of,
so here, this last part, right now there is an internal parameter, this uncertainty round number, which is 35.5, which determines when we have 2 digits or 1 digit.
Yep.
And so this is a way of changing to, for example, 255, and then the error should appear with 3 digits.
Yeah, I understand. So, to my mind, you should just get every parameter you know about, put them in an association, and put them in the, and put them as options to a round form. But I don't think that's essential for the first release.
Okay.
I mean, frankly, I think people are going to like these defaults very much. And I think it's wonderful. By the way, negative numbers do work in a nice way, right? With everything we're doing. Yeah, they just work. You just put a minus sign there. Yep.
Exactly. No problem.
And complex numbers?
Complex numbers work as well. So basically what they are doing is that it's like boxes. The real part of the error goes with the real part, and the imaginary part goes with the...
Okay, so in fact, though, like in the particle data book, as I recall, there are error ellipses in the complex plane, and those we cannot represent.
Well, those would be adding correlations. Those are cases in which we have correlations.
I see.
I mean, if the ellipse is tilted, it means there is correlation between errors.
But if the ellipse isn't tilted, getting plus minus for the real and imaginary parts would be a rectangle, not an ellipse, right? If it just say independently plus minus, plus minus 1 in the imaginary part, plus minus 2 in the real part, that is a rectangle in the complex plane, not an ellipse.
Yes, that's the interpretation. Yes. Yes, it's the product of one distribution times the other distribution, yeah.
Right. But now, in fact, when people give errors in the complex plane, they do mean that, don't they? The rectangle. Even though often in the actual measurement, they've got some phase angle or some such other thing which is uncertain. So they're really in a polar coordinate situation, but they're not admitting that.
I think so. I think so.
Well, so we can't represent that perfectly, but that's life. You can represent it if you put in the correlation stuff. Is that true? Can you represent an ellipse, an error ellipse, even an untilted error ellipse with correlations? Yeah, because you can get to second order.
Yes. But now it wouldn't be a complex number. It would be a pair of numbers. So
yeah, I understand. A pair of numbers with a second order correlation thing that was given.
Right, and on diagonal. Yeah. Mm-hmm.
That would be a nice example to give, by the way.
Yeah. Mm-hmm.
To a polar coordinate conversion. All right. I think we're done with this. Looks wonderful. Any more stuff to be gone over for the around stuff?
Not today, no.
It really looks extremely nice. Okay, so next up. Yeah, go ahead.
Yes, so now we have our standard collection of suggestions, of recent suggestions.
Right. So
this has been suggested a number of times.
This is stupid. This mixed unit thing, that's stupid. That's unreadable, in my view.
Well, that was precisely the type of thing that...
Well, you mean 6 hours, 5 minutes, and 24 seconds and things. I mean, I suppose that might be useful, possibly. But the issue here is, should absolute timing give back something with units? Right? That's the basic question.
Yeah.
And I think the answer is yes, you probably should be able to get that. I think it's obvious the absolute timing was designed 30 years before we had units.
I think at some point it returned a number multiplied by a single second.
Oh, it did. Yeah, that was horrifying. Well, if it did that, maybe we can get away with having it return. I don't know. I'm sure there are many comparisons in the code with...
Right. I wouldn't do it by default. But the idea is to have something that forces the return, like an option or another argument. I don't find it fundamental, but it's true that it has been suggested a few times already.
Well, the real thing is people want it to return that way by default. And we can't do that with the current function with its current name.
Yes, I think it would be quite dangerous to change the
I agree.
output.
I mean, the truth is that the name timing, for example, or absolute timing is kind of a wrong name because it's returning the expression as well. I mean, it would be better in modern naming conventions. It would be something like, evaluate timing, evaluate timed, or some such other thing would actually be the correct form because it is like, re-im of, 3 plus I or something. It's the combination. It's a combination function. It both evaluates and gives timing.
I see what you mean. It's a pair function, yes.
Right.
Though, given the order, perhaps it should be timed evaluate.
Yeah, except that might mean something different. I mean, timing evaluate. Of course, evaluate is kind of the non-function in many ways. It's a function whose name is never mentioned because it doesn't... timed evaluate. See, the problem with timed evaluate is it suggests that it is, well, timed evaluate. It's kind of cruddy, timed evaluate. We've now got also repeated timing. What does repeated timing do?
It's basically the same thing.
And it doesn't have units either.
Right.
But it does have extra arguments.
Yes, a number of times you want to repeat.
Well, No, it's actually specified that at least 1 second should be used to time the operation. Does the repeated evaluation for at least that number of seconds.
But that's why I was thinking that perhaps an option is less jarring here.
Well, I agree, but by the time you've got an option, you could just multiply it by, you could just say, you could perfectly well say quantity of type. Oh, no, you couldn't, because it's a mess.
It's in the first argument. That's why I added a mapped.
Right. Well, so what are you saying? You're saying there will be an option called timing units, arrow, and then you could either give automatic, which would do
or none, would give a number, or dimensionless, perhaps, unit. I think dimensionless unit would be the default.
Well, okay, I don't think this is totally crazy. I mean, it's a little bit in the blarf category.
I mean, having separate functions has the problem that we have 3 already. So we have...
I know. It's horrible.
So, Nick, what do you think about this?
Yeah, I think timing units gives us flexibility. There's always the potential that in the future, if we really want to force it as a default, we could change the option value. But
notice that we have things like this, where that might also be useful, right?
Yeah, well, ping time returns a quantity by default.
I know that, yeah. But maybe it shouldn't necessarily. I mean, in other words, we could do timing units. Ping times timing units would be by default automatic, right? Mm-hmm. But you could, if you wanted to, set it to none, and then it would just give numbers.
Yeah, that would potentially be useful.
Mm-hmm. Is it always milliseconds here?
Probably not. It's probably whatever. It's probably automatic, isn't it?
I'm not sure how Fahim set it up.
Okay, but in any case, I mean, if this was, I think that what we'd have to do is this would have to unit convert to seconds. Right.
But, I mean, it could be nice to have the option here as well, and then by default, we preserve what we do right now. But if the user wants
to... Right. If they want seconds, well, okay, so, no, what I mean is if they say none, timing units to none, see, look, there's 2 different cases. There's convert to seconds and give quantities in seconds, and convert to seconds and give the quantity magnitude.
Right. Right, because if you say units are none, then what is the actual value?
Well, none would probably be the SI unit of time, which is seconds.
Yeah.
I agree.
Yeah, even in the details for ping time, if you're setting update intervals or time constraints, it assumes they're in seconds. So I think it again makes sense to use seconds as the baseline.
So
time.
we should let's imagine that timing units is something which we put into all these places, and the defaults are different between timing and ping time, but otherwise it will work the same.
Mm-hmm.
Seem reasonable?
I think so.
Okay, let's move on. I suspect this is going to be a longer discussion. Let's talk about the synonyms and antonyms function, which I think is very straightforward.
Yeah, I think synonyms and antonyms is pretty straightforward. I did notice that related to, at least in what we have in Word data, related to synonyms, antonyms, and definitions, we also have terms called broader terms and narrower terms, which I don't think are great names. But I wondered if we wanted to do a similar...
Well, they're better than hypernyms and hyponyms.
Right, yeah.
Which nobody would understand without, if you happen to know Greek, you can decode them type thing. But,
yeah, I guess I'm just not sure that broader terms without any additional...
No, it wouldn't work. Yeah, that's not a usable thing for... I mean, then we would have to call it hypernyms if we were to do that. I have to say, I think a lot of those are not very useful.
Okay.
So then the way this would work, I assume, so don't these words also have entities associated with them?
Yes, they're both word entities, and there are going to be word sense entities. So the idea would be that,
Okay, so this is an entity-to-entity creature, but if you give a string, it's a string-to-string creature.
I think so, yeah.
Makes sense to me.
Okay.
I think that's good. Antonyms and synonyms, why not?
Mm-hmm.
I mean, what one means by a synonym is a total mess.
Right.
Right? I mean, in other words, in the space of word meanings, a word, you know, in meaning space, a word represents some block in meaning space. Many words have a, you know, if you say content versus happy, right? Those clearly have an overlap of meaning, but they are not the same word.
Right.
Languages very rarely have two words for exactly the same thing.
Mm-hmm. Yeah, there's always some contextual difference or implied context.
Right. I mean, like these are a good example. I mean, okay, good, bad, evil, that's fairly nice. But these, good, dependable, effective, okay, terrific, you know, but those are very different word meanings. And I think in some time in the future, we will have some notion of, you know, the fact is we already do have a meaning space idea. Mm-hmm. So there is a possibility, if we are to be a little bit more exotic about it, there is a conceivable possibility that there's a synonym distance that we could define, if I'm making sense.
Note that we are eliminating part of that information with this use of last there. So word data good synonyms is reporting more information. Perhaps if you evaluate that.
When are we going to have those blue boxes agree with our other blue boxes?
So you see
well.
information.
Okay, so synonyms, by the way, obviously needs a language option.
Mm-hmm. Yeah. And I know Ben and Alan and the rest of the Word team have been working on standardizing and updating the dictionary sets we're looking at so that they're common across.
Yes.
Same languages available everywhere, etc.
Yep.
Which we'll plug in here.
Yep. I mean, you know, this is all a fake at some level. I mean, synonyms are a fake idea. But I do like the idea of having some, I mean, if you give the word sense entity, then clearly you're going to have a lot more opportunity to get it right in a case like this. Yeah. Someone on our live stream is suggesting rhymes and near rhymes. Yeah, but we certainly have code to do that. I mean, we have, you know, the other kinds of things we have like this that we could expose are anagrams, rhymes, other stuff like that. I mean, ultimately, anagrams or a word is a cool thing to have, and we certainly could have it.
Yeah, I mean, homonyms always are a little tricky because there's so many different types of rhyming too. I mean, I don't think we really need a parameterized homonyms function that's...
Well, right, and I mean, it depends on your accent, you know. Mm-hmm. A boat in Canadian might rhyme with boat or something, but doesn't in American.
Yeah.
Right. Yes, Chandra on a live stream is suggesting a distance metric like the glove distance metric. I agree. That was what I was thinking of, although I don't think that will work very well. I mean, I think that we have, you know, I mean, if we were to do the experiment right now of what words are near, so I mean, if we make a nearest function from word list using a distance function that is, let's see, we want net model of glove, whatever it is, right? Is this going to work? Ag. Is this crazy, or is this? Does this give? Does this do the right thing? If I give that a word, well, in any case, I mean, basically the point is this notion of a distance function. You know, a synonym distance is, I think, a semi-reasonable thing. We don't have a semantic distance function yet, do we?
Not that I'm aware of.
I don't think so.
Sort of implicit in some of the stuff Yihei did, but that's not the same as an explicit one.
Right. Well, I think we avoided it because it's kind of silly and meaningless because, it's like, but this is what we're using. Okay, great. So if we say %14 of, okay, so we actually have to make a distance function that uses this. So if we say good here, it's just going to give a vector of length 100, right? Yeah. So we can make a distance function out of this, and that will be an interesting thing. It will be a nice thing to compare our good exercise for somebody to compare our synonyms function with what you would get from glove out to some distance. That's a fun experiment. I wouldn't mind trying that myself. In fact, I will. Yeah, right. People are suggesting on the live stream various kinds of grammar rules and so on. Yeah, we know there are other things one can do here. I mean, the problem is it gets very, you have to start worrying about dialects and all kinds of horrendous things. I mean, we're just now putting in the spelling dictionaries with, British versus American, and yeah, it's really complicated. I think though that just for the plain, let's get an antonym, let's get a synonym, that's useful. There will be some nice exploratory things. Yeah, somebody's asking for synonyms for multi-word phrases. Boy, you guys ask for everything.
I should point out that the American version of that thing is always American versus British, never British versus American.
Did I say it the wrong way around? Sorry about that.
It depends on which side of the pond you're on, I'm sure.
Okay, look, I think for right now, just the simple synonyms and antonyms functions seem fine to me. The question of synonyms for multi-word phrases, we can ask Alan and team what is happening with that. But complicated mess.
Yeah.
Okay. Can I let's look at these comments on subset map, and then I want to very briefly go to the phone number stuff. Oh boy. Okay, so is there a bottom line here to what okay. Subset map. Sort. Okay. Yes, that would be beautiful. Organization of data series. That's interesting. So the all case of subset map, okay, issues with the proposed syntax. And the in-place form, what is the in-place form? Ay. Okay. So what would you do? I'm sorry, the in-place form here would say what? That would be saying apply that function to, so you say list of all, 3 at equals f would be equivalent to subset map. List equals subset map of list, of f, list, all, 3. Is that right? Shall I write that out? So you're saying here, list all, 3 at equals f is equivalent to list equals subset map of f, list, all, 3. Is that right?
Right. Though, yes, something like that. I'm a bit confused between, again, party specs and struct spec, because all this list all, 3 is a strat, but yes, he was looking for something like that.
By the way, someone on our live stream is pointing out how great our language is for education and how language learning is part of that. And I thoroughly agree with that, which is why I've been pushing a bunch of these language things. It does occur to me, do we have something which checks whether a word is spelled correctly?
We have Dictionary Word Queue, which does that. We originally were thinking about calling it Correctly Spelled Queue, but it's awkward. And we have Spelling Correction List, which gives a list of possible corrections and returns none if it is.
What is in the front end? Is it something that is not actually exposed functionality?
So we use the same library. It's basically the kernel is calling the same thing that the front end is, but they're not. The front end's not using a kernel, and the kernel is not calling the front end directly. They're both calling into the same utilities.
Okay.
But our spelling dictionary, which we add to practically every day, is flowing through to all of those places, right?
Yes.
And why did this does this go out, is this a certain number of words or does this go out to a certain distance?
So we use the same default distance parameters that are given by the library. We don't currently have a
this
parameter.
Is fairly stupid, in my opinion. I mean, what it's doing here. And I don't know why it's got proper names. Well, I guess it should have proper names, but that's a... So there's no parameter here that says, give me 20 spelling correction words.
There isn't at the moment, but we could certainly include that.
Okay. Might be worth doing that. I mean, it may be worth looking at what the and does the spelling correction list work for does it work for languages other than English?
Yeah,
should, right?
We plug into the same.
Magnificent. Okay, and it works for multi-word as well, right?
Yes.
Okay. All right, I'm sorry, back to this subset map thing. Okay, so what is issues of the proposed syntax?
I think this is less important. He wanted to be able to act on several columns at the same time, and he was wondering how to do that. But to me, the most important thing is having a different look at the functionality from this set versus art point of view. Because for the name...
Yes. I think the name is, honestly, I'm not completely sold on the name now, because as we start seeing more and more uses of this thing.
The last name you suggested was Map Across.
Okay. How do people feel about that name?
I still prefer subset map, but...
Right. Okay, so wait a second. So let's go back up here. So multiple columns.
Mm-hmm.
I want two lists, one for each column instead of a list of pairs.
Right. So the idea is all 2,3 is that a list of all pairs or two columns. So it's the transposed of one another.
Wait a second. What are you saying? So this one here, is that right?
Yes. So he's suggesting another notation to avoid the ambiguity with all list to 3, which would be the list of pairs, where he wants to act on 2 columns.
Oh, I'm totally confused here. So we have subset map of F, and let's say F is a matrix.
Acts on a matrix, yes. So
right. So here, all comma 2.
Yes, that's the list of
what?
That's the second column of change list to matrix.
Okay, but what does this do now?
It will take the second column. F will get that column. It will return another column, and we'll put it back. So imagine F is accumulate.
Okay. So it gets one gulp of the whole column.
Right. Now, what he's saying is that if we use all, 2, 3, it will get a list of pairs. But he wants...
Wait.
Yeah.
It will list of pairs. What kind of pair? Wait a minute. What kind of... It will get a list of pairs from column 2 and from column 3. Is that correct?
Right.
Okay, so the question is, how can you operate with F being fed the whole of column 2 and the whole of column 3?
Exactly.
And is there a proposal for how to do that? I mean, in other words, one way to do that, I would have thought, would be to just say all comma 2, all comma 3. Am I mistaken?
Well, that's something we don't support right now in extract spec, but we could.
Probably could.
We could. He was actually suggesting something similar, but with a specific head called part list.
Yeah, I understand. I mean, decorating that, just like we have things like span and so on, I would say those decorations have been only mildly successful.
Well, as long as there is no ambiguity, this is fine, but we have to check that it doesn't lead to any ambiguity.
Let's check.
Mm-hmm.
Ethan Black 86 on our live stream is suggesting map into as a possible name for this creature. And someone else is saying that all 2, all 3 is ambiguous. Why? I don't think so. I think that represents a column. What do we think about map into? So map at says do it at these points. And I don't think into is quite right. If it's going to be a preposition like that, it's got to be something like across.
Yeah, I think across works better here, but
yeah, and Ethan Black 86 is saying map column would be nice syntactic sugar. I agree with that. I am still pushing for a map column or column map. The problem is, where does it end? You know?
Right. And we still have the issue of whether it's mapping on the elements of the columns or on the column itself.
Okay, so the ambiguity comment is if we take something like this, wait a minute, what does that mean? Subset map of F.
I would interpret that as 2 positions, extracting 2 positions of a matrix.
Okay, but why isn't that? Okay, so that's saying that subset map has to be folded in order to do multiple applications of F. See what I'm saying? If you want, so subset map is just doing a one-shot.
No, but I think F should always get all the elements at the same time. And then it returns something of the same structure and puts them back.
Yeah, I understand. Whereas map at can zap, can insert F in multiple places. Exactly. What this is saying is it can only insert F in one place.
Right, the same places it extracted.
Right, which makes the word map a little bit confusing.
It's an extension of map.
Well, it's a D extension of map in some ways because map typically puts F into many places in an expression, where this is putting it into one place in an expression, if I'm not mistaken. So this is a single application of F.
Yes, yes.
I mean, it's almost... Oh, I don't even know. It's. I mean, this idea of a single application of F. I mean, it's kind of more like. It's not like Curry, because Curry takes arguments. What this is doing is it's. Yeah, what the heck is it?
Apply. It's not applied, because apply for us is always replacing head.
Yeah. All right. Okay. And you might argue that mapat. I mean, the problem with mapat is mapat can have a list can have a list of positions to map at. Whereas what this is doing is it's taking a single block of data. Well, it's taking two blocks of data. It's always two, right?
Why two?
Well, because it's doing.
It's a list of subparts.
I see. And F is applied to those subparts, and it always has to give a result that is the same shape as those subparts.
Exactly.
And that then will. Map in place. The problem with that is it suggests that it's in place in the sense of memory.
Right. Yeah.
And in a sense, map is always in place, so that's a silly name. Well, subset map is not sounding horrible still. Subpart map. Don't think it really helps anything. I still don't think it's a perfect name. Transform part. Is the name suggested here? Okay, so the question of whether this case here, what does this case here mean?
It will extract matrix of 1, 2 and matrix of 3, 4, put them in a list, apply F, and then put them back.
Right, so two single elements, apply F to them.
To a list of them.
Yeah, to a list of those. Right, because it's not an apply, it's a map.
Right, exactly. It's a construct of F, comma, the list of elements.
Right. Well, fair enough. I think that getting, I think nothing is dead yet here. Now, in terms of this form, I don't know. Let's, you know what? I mean, this is amusing, but if what that would imply is, that's an append to. So this will be a subset map to.
Right.
And we don't even, what's that?
Yes, exactly. It's a two version of subset map.
But we don't even have, a map to.
Mm-hmm.
We've never needed a map to.
Right.
Or a map at to. So I think it's just not that hard to say list equals this. It just doesn't seem to me that it helps anything to have a totally funky syntax.
Mm-hmm. Okay.
So I think we should keep going with subset map unless we can come up. I mean, so far that name is the least bad name that I've seen for this.
I agree.
All right. And I'm afraid let's just take a very, very, very quick look. And I know I have to go to another meeting here. Let's see. By the way, did we sort out, and it's probably not for this meeting, the business about smile strings and the chemical name business? That's probably not for this meeting. I don't know if Sushma knows about that.
No, I don't know about that.
Okay. All right. We are going to end up having to have these wrappers, and they are part of the world, and I don't see why we shouldn't have them.
So phone number and physical address seem good to me. Person, I was a bit more worried because we have person data. And I was wondering, what's the difference?
You're right. You're right. It's not person. It's a name of a person.
Right, because phone numbers and physical addresses is something that, may change even in time. But person has a more historical sense to it.
Well, yes, the person in the current state of the world, a person is a very distinct entity that, lives a certain time and there's no cloning of it and so on. Right? I mean, if we were describing personhood for worms, where you can split the worm in two, then we would have a different story. But since that isn't the situation with humans, right, there's a different notion of person than, right. So I agree with you. This is person name. And in fact, person, even if they change their name, they are still the same person, right, but they have a different person name.
Right.
Yeah, I agree. But the point about person name is that it matters whether it's Smith, John, Professor, Dr. John exactly. Smith, et cetera, et cetera, et cetera.
Exactly.
So I agree with that. It should be person name. But now in terms of things like phone number, I agree that we should have that representation. And I suspect we would be able to still change what interpreter returns for this case. No, we don't want to do entity phone number because it's the same thing as with molecules, right? There are an indefinitely constructible number of phone numbers.
Mm-hmm. Right.
And it's more like integers than it is like cities where, okay, all right, I admit philosophically there's sort of a, you could construct an indefinite number of cities too, but there are a certain set of, legally incorporated cities or something in the world. Mm-hmm. So I think, it's the right thing is to have a wrapper. And exactly what the form of the wrapper is, I think there's a nice canonical representation where we basically have the full phone number string. We have like the area code broken out, the country code broken out, and so on.
Right.
Okay, this is a separate meeting. I don't know who's going to lead that. Nick, is this going to be in your area, or who's going to be dealing with the actual output here? I think Carlo B had been the person working on phone number parsing, if I remember correctly. And I suspect he has opinions about that. I know in terms of the person data thing, which is the thing we really need to, the person name thing, that's something we really need to solve for all kinds of reasons for the ERP project and so on. Physical address is another can of worms. I don't know whether, physical address in having a good representation of that in like a country like Japan seems complicated. I don't know. Does anybody know the, like in, a typical form will say, street, what is your street address? What's your, a typical American style form will say street, city, state, country type thing. What does it do in Japan, for example, where the addresses are?
Japan, you typically have a similar setup. You have building number, you'll have ward within the city prefecture, etc.
So it's hierarchical. So in the case of, in all of these cases, one's thinking about it as a hierarchical specification. It's just that in the US case, it's okay, fine. You have a one parameter family in the case of a street, whereas in the case of what you're describing there, it's a two-dimensional blob of area. Is that right?
Generally, yeah. You still have street addresses, but you tend to break them down into extra hierarchies. I know there are some places like Mongolia where it's harder because you don't generally have the same notion of a physical address, but how that's handled, I'm not really familiar with.
Right. Yeah, right. No, I know that's what that crazy idea of having the 3 words that represent a location on the Earth.
Oh yeah.
Popular in Mongolia for some. I don't know. That was really popular, or that was just some media nonsense. I do know. I mean, there are funky things like the case in, I think, Phnom Penh in Cambodia, right, where the street numbers are random because they were based on when the historical order in which things were occupied, rather than their position on the street. But we don't have to worry about that because we're not dealing with proximity that way. But that's just for the geocoder. We have to worry about that.
Yeah.
So, okay, fair enough. Well, I think we need, let's pick this up at a different time. Do other people need to be in the meeting to discuss person name and so on? I suspect they do. I think Alan
probably Alan at least, yeah.
And I think Carlo should be there for the phone number 1.
I would add Francisco for physical address because he has worked with Nominatim in Chilocas. Yeah,
okay, great, fine. So can we, and then let's also add, we should probably add Daniel Bigham.
Okay.
Since he's a consumer of this stuff. Okay, last point here. Seth Chandler is saying there should be an operator form of subset map. Don't we have an operator form proposed for subset map?
Yes, indeed. With 2 arguments, the function and the positions.
Yeah, okay, fine. That's the correct thing. Yeah, there it is. Yeah. Okay, well, I think that's all we have time for right now. Thanks everyone here, and thanks to our live stream. Lots of good comments today. Thanks a lot. See you all soon.
Thanks, everyone.
Bye.
Bye.